Good morning, guys. Myself, Sridhar H., working as an assistant professor in the Department of Electronics and Communication at Government Engineering College, Haveri. Today, we are just going with the session 8, that is flip flop 2 in Basic Electronics, Module 5, Digital Electronic Fundamentals. In the previous session about the flip flop, we have just studied about the SR, that is set, reset, flip flop. So in that set, reset, flip flop, we people are having the three states, that is no change state, set state, as well as the reset state, and the last state was the forbidden state. To overcome that forbidden state or the intermediate state, we people are going for this JK flip flop. Okay, JK flip flop is basically a gated SR flip flop. Okay, just to avoid the intermediate state, we just going for this JK flip flop. It is just almost it is acting like as a SR flip flop with addition of clock input circuitry that prevents the illegal or invalid output condition that can occur when both inputs S and R equal to logic level 1. Due to this additional clock input, a JK flip flop has 4 possible input combinations: logic 1, logic 0, no change, and toggle state. That is, logic 1 means set, logic 0 means reset, no change means the previous state, and well as the last state. What it was initially for SR flip flop, it was intermediate state, and in this state it is a toggle state. Okay, so this one is just the JK flip flop. As already we know that the flip flop will having always the two outputs, one is Q and another one is complement of Q, that is Q bar. Okay, next. So in JK is basically a SR flip flop, means J is representing for set and K is representing for reset. Okay, for J is S and K is equal to R. Okay, so this one is the block diagram. So this one is just the combinational circuit of a JK flip flop, where the SR flip flop is connected with one AND gate, all that is along with the J, and the complementary output Q bar is being connected with the J along with the AND gate to S. In the same fashion, for K along with the AND gate, the output of Q is been connected. Okay, next. So it is been status that, so this one is just the AND gate. So if you want to change the by using only the NAND gates, okay, so by using only the NAND gate, the circuit looks like almost it look like the same SR flip flop. Only thing is what, in SR flip flop we people are using only 4 2 input AND gates, NAND gates, but here we people are using 2 input NAND gates 2 and 3 input NAND gate 2. See here, one input is for the clock, another one is J and K, and see here, the Q bar is connected at the top end of the NAND gate and Q is connected to the knob. That is, this one is the feedback circuit. Okay, as we know that the sequential circuits, in the feedback circuits, Q is connected back to the along with the K and Q bar is connected along with the J. Okay, so this one is the important factor. What is the difference between SR and JK is the only one thing is in that thing, so there is no feedback connection for the inputs. Okay, but the internal feedback will be there, but there will be no external. That is, the Q bar will not be connected to J input along with J input, and Q will not be connected with the K input. Okay, the remaining things J and K. So instead of S, J is can be changed to S and K can be changed to R. So when S is 0 0, it's a unchanged state, that is the previous state. So 0 1 means the output will be 0, that is reset. 1 0 means 1, that is the set, and 1 1, the intermediate state has been changed to Q bar T as the previous output inversion of whatever the output to the previous output it will be, that it will be just changed. That is, the Q of T will be, now it is for 1 1 it is a Q bar T, that is a toggle state. Operation of JK flip flop. So these are the 4 cases what will be just going through here. When both the inputs J and K are low, the Q returns its previous state value, that is, it holds the previous data. Okay, the same thing. So J and K, the NAND gate, if any one of the input is 1, the output will be 0, as what we people have been just gone through the SR flip flop, the same states what we people will be just cross checking. As we know that the clock will be always 1, J and K will be what? 0, 0, and we will assume certain value for Q is equal to something and Q bar is equal to, means if Q is equal to 0, obviously Q bar will be 1. Along with that state, if you just cross check, so we will be getting the unchanged, and whatever we assume the value, the same thing what we people will be just getting. When we apply a clock pulse to JK flip flop and the J input is low, then irrespective of other NAND gates, the NAND gate 1 output becomes high. Okay, means if any one of the input is 0, the output is high. In the same manner, if the K input is low, then the output of NAND gate 2 is also high. So thus the output remains in the same way, that is no change in the flip flop. Okay, when J is equal to 0 as well as K is equal to 1. What we'll be doing is, you can assume the value Q is equal to 0 and Q bar is equal to 1. So Q is equal to 0 means this one is connected along with this one, we will be getting it as 1, and here it will be getting it as 0. If any one of the input of an AND gate is 1, 0, so 0, 1, it will be what? The same thing what people have been assumed. Okay. Next case 2, when J is low and K is high, then flip flop will be in the reset state, that is Q is equal to 0 and Q bar is equal to 1. So when J is equal to 0 and K is equal to 1, so it will be in a reset state. When we apply clock to the JK flip flop, the input, the J is low and K is high, the output of NAND gate connected to J input becomes 1. See here, J is equal to 0, it will be 1. Okay, and K is equal to what? It will be 0. So whatever the previous value, if anyone once again 1 it means, obviously it will be a 0. So here it will be 1, and so here the output what I will be getting it is of a 0. Okay, when then Q becomes 0, this will reset the flip flop, and again it points to state, so the flip flop will be in a reset state. Case 3, when J is and K is low, then flip flop will be in a set state, that is Q. When we apply a clock pulse to the JK flip flop and the inputs are J is high and K is low of the NAND gate connected to K input becomes 1. See here, when J is 1 and K is equal to 0, K is equal to 0 means any one of the input is 0, the output is 1. Okay, if any one of the input is 1 means the K is 0 means it will be getting it as 1. Okay, so 1 means, so obviously it will be having a previous output, so 0, so we will be getting the Q is equal to 1, 1 is equal to 0, so 0 and 0 it will be what? 1. So and the Q bar will be 0. So J is equal to 1 means obviously it is output Q is equal to 1, that is in a set state. When both the inputs J and K are high, then the flip flop is in the toggle state. This means that the output will complement of the previous state. Okay, so in this indicates that for J is equal to 1, K is equal to flip flop output toggles, meaning when Q changes from 0 to 1 or from 1 to 0, and these changes are reflected at the output pin Q bar accordingly. Okay, that is the major change what people are been just coming across the SR flip flop. Okay, see here, this one is the thing. So and this one Q bar, so what is the toggle state is been known as the raise around condition, that will be just looking up here during upon the clock. So when there is no clock applied, whatever it might be the inputs J and K, always it will be having the previous output. So when during the clock when high, when J and K is equal to both 0 0, that is a no change state. When 0 1, it is a, what is the value? G1 is it will be a 0, that is a reset state. When J is equal to 1, so it will be in a set state. When 1 1, it will be in a toggle state. So now, so this one, the raise around condition of the JK flip flop, for high inputs of J and K, only the lower NAND gates are triggered by the outputs that are complement to each other, that is Q and Q dash. So while the high inputs are connected to flip flop, at any instant one gate is enabled and other gate will be disabled. Okay, so this one is the raise around condition, why it is been conditioned to. Okay, if the upper gate is been disabled state, it will drive the flip flop to set state. Later when the lower gate is enabled, it will drive the flip flop to reset state, which causes the toggling of output. Okay, this is raise around condition of a JK flip flop. Okay, so to avoid this one, so we will be using the master slave, this one. To avoid the raise around condition, we will be just going for this master slave JK flip flop. Okay, so master slave flip flop basically a combination of two JK flip flops connected together in series configuration. See, two JK flip-flops connected in series. One acts as a master and another acts as a slave. The first one will be acting as a master and another one is acting as a slave. The two output from master flip-flop is connected to the two inputs of the slave flip-flop, whose output is fed back to the inputs of the master flip-flop. See, the output of the first flip-flop, that is the master flip-flop, is acting as a input to the slave flip-flop. Okay, another thing, the slave output is been fed back to the what? The master flip-flop. Okay, next. In addition to these two flip-flops, the circuit also includes an inverter here. So why this inverter is means, we will be just giving a direct clock to the master flip-flop and a inverted clock to the slave flip-flop. It means when J is when during the high state, that is from 0 to 1, the master will be on. From 1 to 0, the slave will be on here. The inverter is connected to clock pulse in such a way that the inverted clock pulse is given to the slave flip-flop. In other words, if clock pulse is equal to 1, master flip-flop is on, then it becomes 0 for the slave flip-flop. So when clock is equal to 1, the master flip-flop will be on. 1 means 0. 0 means the slave flip-flop will be in a off state. When clock is equal to 0, the master flip-flop will be in off state. So clock will be what? 0 means it is noted in, it will be getting Y, means slave is on. So whatever the master output is there, that will be acting for the slave, this one. A master flip can be constructed using 2 JK flip-flop as shown in figure. The first flip-flop is called the master, that is driven by the positive clock, and the second flip-flop is called the slave, that is driven by the negative clock. So this one is the master flip-flop and it is been active during the positive clock, and this one, the second is slave, so this one is active towards the negative clock. Okay, and this one is the main important thing. For master, direct clock is given. For the inverted clock is been given to the slave. Only thing is why means during the positive clock cycle, the master is on, and during the negative clock cycle, the slave is on. Okay, gives the intermediate output, but the slave does not. During positive clock, master flip-flop gives the intermediate state. Intermediate state means during the positive cycle, the master JK flip-flop will be in a on state, means you will be getting certain values here. So these values are known as the intermediate state, which is acting as the input to the slave flip-flop during when the clock pulse becomes negative. So when the clock pulse is negative, it is being converted to a inverter to a positive clock. At that time only the slave will be on. Okay, during negative clock, the slave flip-flop is active and it copies the previous output of the master flip-flop and produces the final output. Okay, when this one is active, it copies whatever the output is being mentioned from the master flip-flop. That one will be acting as the output here. Okay, so whatever the master input will be having, that thing will be just copied out into the slave. Next, so this one is just the block diagram, means the schematic diagram of this representation of this block diagrams here. The NAND gates, whatever it has been. So you see here 2 NAND gates. So this one is the structure of this. So this one is the 3 input NAND gate. The Q bar is being connected along with the J, and Q is being connected along with the K. Clock is directly given to the master flip-flop, and clock along with the inverter is connected to the slave input. Okay, so these are the first one. Whatever might be the clock, if the clock is means if we are not giving clock, whatever might be the inputs, so it will be in a previous state. Okay, and during the second condition, when clock is high, so 0 0 means if J and K both are 0 0, obviously it will be in a no change state. When next clock, when J is equal to 0 and K is equal to 1, it will be in a reset state. When J is equal to 1 and K is equal to 0, it will be in a set state. And the last 1 1, so it will be in a toggle state, that is it will be having a complementary output. If Qn bar is there, we will be getting Qn, even if it can, then it will be having a Qn bar. Okay, so we'll just cross check with all the 4 cases. First case, when clock is not given, both the master and slave are inactive and there will be no change in outputs. As we know that it is a sequential circuit and it will be having the previously stored value, so we will be telling it as no change value, means whatever the previously stored value will be, the same value will be just coming across. Next, case 2, for clock is equal to 1, master is active, slave is inactive. When clock is equal to 1, master is active and clock is, so that is the slave is inactive. Okay, as j is equal to k is equal to 0, output of master is q and q dash will not change. Okay, so master whatever they will be having when j is equal to 0 and k is equal to 0 will be having certain previous value, whatever it will be stored, the same value will be changed. Once again, when clock is equal to 0, at that time the master will be in a inactive state and the slave will be in a active state. Whatever the output will be coming across from this master, the same thing will be copied across from this slave and will be getting the output. That is, whatever the previously stated value will be having, the same value will be coming across at the output q and q bar. But since input to slave is r is same, output of slave will also remain same. So case 3, when for clock is equal to 1, master is active and slave is inactive. When j is equal to 0 and k is equal to 1, output of master will be what? Q is equal to 0 and q dash is equal to 1, which will be inputs to slave. When clock is equal to 0, slave becomes active and takes input 0 to give the output. Q is equal to 0 and 1. See, when j is equal to 0, k is equal to 1, during the positive clock, what is happening at this time? The master, only the normal first master JK flip flop will be working. So at that time, when j is equal to 0 and k is equal to 1, obviously q is equal to what here? The intermediate state output q is equal to 0 and q bar is will be 1. And during the negative cycle, what will happen? The master means it will be the whatever the value will be having, the same value will be having in D, and these value will be copied to the slave output when the clock is 0. 0 means it will be 1 and the clock, this slave will be in a active state, means whatever the output will be having, that is q is equal to 0 and q bar is equal to 1, the same thing will be getting at a output, that is q is equal to 0 and q bar is equal to 1. That is, when j is equal to 0, q is equal to 0 means it is a reset state. Next case 4, the same thing, when clock is equal to 1, master is active and slave is inactive. So when j is equal to 1 and k is equal to 0, output of the master will be what? Q is equal to 1 and q dash is equal to 0, which will be inputs to slave. When clock is equal to 0, slave becomes active and take point of the output as q is equal to 1 and q is equal to 0. If q is equal to 1 means it is in a set state. Means normally what it is happening is, so whatever the JK means, when during the positive cycle, master output we are getting, and when clock is equal to 0, at that time whatever the master output is been getting, that is copied from the slave output. Okay, see, when case when both when clock j and k is equal to, master output will be toggle, so s and r will be invert, but slave remains inactive all these times since clock is 1. As soon as clock becomes 0, slave becomes active and master becomes inactive, so slave will be also be a toggle state, means only during the positive cycle master is on and during the negative cycle slave is on. Means during the positive cycle, whatever the output we have got at the master flip flop, that the same thing will be copied at from the slave flip flop. These changed outputs are returned through the feedback to the master, but master does not respond to them because clock is now 0 and master is inactive. Thus, in one clock period, master and slow both toggles only once, avoiding the race around condition by multiple toggling. Okay, to avoid this race around condition, we are just going for this master slave JK flip flop. Okay, the output waveforms of a JK flip flop. Okay, during the positive cycle, during the rising edge as well as the falling edge. So when 0 0, q is equal to 0 and q means whatever the previously stored value, that will be just getting. So when j is equal to 1, k is equal to 0 means we will be getting at a, so this one is just considered for the normal output of a JK flip flop during the positive edge. Okay, so when it is 1 1, we will be having 0 1, so q dash is equal to 0. See, for 1 1 it will be 0 1. When both the clock pulse and output of the master is high, then it is remains high until the clock is low due to the state is stored. It will be having a previously stored value. At this present, the master output turn into the low and clock pulse turn into high once more and remains become low till the clock turn into once or once more. See, whatever it has been, it will be having the retained value. See, during the previously stored 0 0 means it is having a previously stored value. Previously stored value is what here 1, so it is just goes on continuous for until the what, during the next positive cycle. So 0, though it has been changed to k1, it will not be changing at this time. It will be changing only during the next positive half cycle. Therefore, the toggling takes place for the clock cycle. Whenever the clock pulse is 1, master is set, however not the slave. Therefore, the slave output remains 0 till the clock remains 1. Okay, means whatever the input will be having, output will be having, or the master, that will be copied to slave when only the clock changes from high to low. When the clock is low, then the slave turns into operational and remains until the clock returns to 0. Toggling takes place throughout the entire procedure while the output is alternating one time with the cycle. This makes this flip-flop as a synchronous apparatus because it passes only data with the clock signal time. Okay, now, so the two flip-flop, that is the D flip-flop. The single input, D flip-flop means only one input will be having. The single input is called the data or the delay input. Means whatever the input will be having, the same will be the output. If this data input is held high, the flip-flop would be set, and when it is low, the output change becomes to reset. That is, when D is equal to 1, the flip-flop is set to be set. If D is equal to 0, the flip-flop is set to be reset. The output of the flip-flop would always change on even impulse applied to this. That means whatever the input will be, the same will be the output. That's so it was known as the data input or a delay input. So this flip-flop will be related. Whatever the input will be, the same will be the output. Mean for that reason, we are telling it as a delay. Means wherever we require a delay, sometimes this D flip-flop will be used. Okay, as we know that a normal clock is there, only one input is there, that one is the D input, as well as the flip-flop will be having always two outputs, Q and Q dash. Input is D, means if D input is 0, Q is 0, Q dash is 1, and if D is 1, Q is 1, Q bar is 0. Okay, next, how this SR flip-flop can be converted into a D flip-flop. Okay, see here, the SR flip-flop, this one is normal block diagram. Since only one input is there, so D is directly connected to S, and the R is connected with the inverter. If the R is connected, means D is 0, means D bar will be what? Here it is also be 1. So 0, 1, whatever means whatever the input will be having, the same will be the output. Means S is equal to 0 means you will be getting it as 0. So D is equal to 0, S is equal to 0 means Q clock pulse will be dash what? 0. If D is equal to 1, S is equal to 1. So obviously what it is, R is equal to 0. If S is 1, then obviously Q bar QP is equal to 1. So whatever the die input will be having, the same will be the output. If D is equal to 0, QP will be 0. If D is equal to 1, QP is equal to 1. See here. So this one is a normal SR. If you get it, SR flip-flop means directly D is connected to the S and the R is connected with the inverter. Okay, the same input. Since the data D flip-flop will be having only one input. Next, the T flip-flop. T flip-flop has only one state, hold and toggle. Okay, when it is B0, it is telling it as hold, and when it is B1, it will be having a toggle. In toggle mode operation, the output will toggle from 1 to 0 and vice versa. Okay, next, how to convert from SR flip-flop to T flip-flop means the S and T directly we can just connect towards the S and R. If we should just shorten, means both S is equal to 0, 0, what will be getting the output as 0, whatever the one you will be having it as the previously state stored or the toggle state. Normally the T flip-flop can be used by using normally the thing what a JK flip-flops here. For JK flip-flop, J and K are being just shortened and directly given with the only T input. Okay, T is equal to 0 means previously stored value. When T is equal to 1, what will happen? It will be having a 0 and 1 state, that is a toggle state. Hold state means it will be having a previously stored value. Okay, the same thing what they have been mentioned here. One means directly for SR or the JK directly, if J and K are be shortened, that one is known as a T flip-flop, or S and R also if we shorten directly we will be getting it as a T flip-flop. For D flip-flop, what we are doing is connecting with one input directly. S is being connected directly with the D input and R is being connected with the inverter, but in T directly S, J and K are being just shortened. Okay, so this one is the end of this flip-flop 2, that is we will be just going through the JK flip-flop. Okay, why people are going for JK flip-flop? Just for to overcome the forbidden state what we people are getting for the fourth state in a SR flip-flop. Okay, next, and in a normal JK flip-flop we people are coming across the race around condition To overcome that race on condition, we people are going for this master slave JK flip flop. And the next is the delay flip flop. Delay flip flop, that is J and K or S and R can be connected with the inverter, then shortened with the inverter, then it is converting into a D flip flop. And for T flip flop, directly if we just shorten without any inverter, then it is known as a T flip flop. Okay, thank you.